Hello everyone, let's discuss this problem, yet another matrix problem, and the problem rating is 2300. But this is quite a simple problem, I assure you of that. And let's read the problem statement first. You are given an integer and we need to generate a matrix A of size n cross n such that every aij is a distinct integer in the range 1 to n square, and the boundary sum of all the square submatrix from A11 is odd. So what this means is let's say we have a matrix of 3 cross 3. So and we are considering all the square submatrices. So one such matrix is this. Next one is this 2 cross 2, and next is 3 cross 3. All the square submatrix whose the top left corner is 1, 1, and we want to take the boundary sum. So basically we want to take the sum of this one, 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 this one. So sum of the boundary elements of every square submatrices, and this sum should be odd. And we want to find such a matrix whose which satisfies this condition for all the squares possible. If no such matrix exists, print -1. If multiple such matrices exist, you may print any of them. And you can read the input and output format. In the output, we need to print the whole matrix if it exists. N goes to 1000, so an n square solution will work here. And we can see for n equal to 2 there is no possible solution, and for n equal to 3 one such possible matrix is this. How is this correct? Let's just see that quickly. So this is the sample input for n equal to 2. The answer is -1 because since we have elements 1, 2, 3 and 4, no matter how we arrange them, this 1 cross 1 can have odd, but the sum of whole matrix will never be these 4 elements will never be odd, right? So the answer is -1. For n equal to 3, the answer is 917, okay, 548 and 632. So for 1 cross 1 it is satisfied. For 2 cross 2, I have to take the sum of boundary elements, which is 9 plus 1 is 10, 10 plus 5 plus 4 is 19, so this is also correct. And for n equal to 3, I have to take the sum of these elements except 4. So I think you can take that, but it will also be odd, so this answer is correct. And we need to find any such permutation. So now let's discuss this approach. Okay. Now what's important here to understand is that the actual values do not matter. Let's say for n equal to 3, if I make a 3 cross 3 matrix, then we can put here any number, like but it should be odd in the first 1, 1. In here we can actually put any number between 1, 3, 5, 7 and 9, but it's just that the first number should be odd, right? So I can simply say, okay, I will put an odd number here. Then in this 2 cross 2 submatrix, I have several possibilities, like I can even put 2 odds and an even, or I can say, like, let me just draw it quickly. I can even put 2 all evens, right? Both will work to satisfy the 3 cross 3. But in the last case, like if I have if I have this case, then I have an odd, 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 even, and then rest of the elements I will have to put in this area, right? So we have 1 2 3 4 5, 1 2 3, odd, odd, and rest will be even. Okay, and in this case I will have in this case I will have odd, even, 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 and then I have 4 more odds. So odd, 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 and then an even. So if you see, like for this matrix 1 2 3 4 5, this is satisfied. So this is actually a correct answer. I can simply put my odd numbers at these positions and even numbers at this position, and for n equal to 3, this is one possible answer. Okay, but let's not consider this. Let's see this one as well. What is wrong here is that in this last the 3x3 boundary elements, we see that if I had one more 0 in this last boundary, then it would have worked. So what I can do is I can swap these even and odd and make my matrix something like 0 0 e 0, I mean odd, then rest of the odds and evens, and this is a possible solution for n equal to 3. So I hope you are trying to understand, you get it what I am trying to do. Let's also solve for n equal to 4, and I think you will understand. So for n equal to 4, we have numbers from 1 2 3 till 16, right? So we have 8 odds and 8 evens. Let me make a 4x4 matrix. So 1 2 3 4, 1 2 3 and 4. Right, now what we can do is okay, first one should be odd, right? Then we are left with 7 odds. So I'm not writing the evens, but what I can do is I can put 2 evens here, so 2 odds here. So in this whole 2x2 submatrix, I have 3 odds, which will make the sum odd in this whole and now if I see in this 3x3 matrix, I have 2 odds. So what if I put 3 odds here? Then you can see that I have 1 2 3 4 5 odd numbers in this and here I will put my even numbers. I'm just not writing them. So in this 3x3 submatrix, I will have 5 odd numbers. And how many odd numbers I have left? So 3 4 5 6. I have 2 odds left here. And now if you see in this 4x4, I have 1 2 3 4 1 2 3 4 5 odd numbers, and rest I can place even numbers. And this is my answer for 4x4. So what I'm trying to do is I am trying to fill my upper triangular matrix with as many odds as possible. Let's also see another case for, let's say, n equal to 6. I think this will be a better case. Okay. Now for n equal to 6, we have numbers for 1 to 36. So 18 odds and 18 evens, right? So let's try putting odd numbers, as many as we can, in the upper triangular matrix again. So we have I will change the color. Let's say 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16 17 18. Okay, so now in this case, like if you see, like in this 1x1 I have 1 odd number. In this 2x2 I have 3, so that works. In this 4x4 I have 1 2 3 4 5, so this is also correct. In this 4x4 in this 4x4 I have 1 2 3 4 5 6 7, so this is also correct. In 5x5 I have 1 2 3 4 5 6 7 8 9, so in this 5x5 I also have 9 odds, so that will make the overall sum odd. So in till 5x5 I have 9 odd numbers, so this is correct. and in the 6 cross 6, 1 2 3 4 5 6 7 8. Now this is wrong, like till 5 cross 5 I have correct, but in the 6 cross 6 I will check. If I check 1 2 3 4 5 6 7 8, I have 8 odds, which is not the correct. Now I have to switch somewhere, swap some elements to make the number of odds in the last boundary as odd number of odds, right? So to do that, one way would be to switch, like try to bring in some odds here, but that will not work. So what we can do is we can take this odd number in the n-1 cross n-1, the last this matrix, and shift it from this position to this position. So if I will swap these two elements, and if I do that, what will happen is it will not disturb the number of odds in my smaller matrix, but it will increase the number of odds in the bigger matrix by 1. And what I observed is that no matter how big our n is, whether it is odd or even, it does not matter. But like if it is an but if some error is occurring here, like if I am lacking one odd number, what I can do is I can shift this odd number from here to there, and that will solve my problem. So that is the approach, and I hope you were able to understand it. I will just once we have this matrix, I can place all the even numbers in these positions, and this will give me a correct answer. I mean, you can even try to verify this. Now once I have this matrix ready, I will just put all my odd numbers in these positions and my even numbers in these positions. And if you think coding this traversal is hard, let's code it together, and you will see how it is. You will see how easy it is. Okay, so let's make a new file and let's see. Okay, so first thing first, I am going to put all my odd elements in. Okay, let's first take the integer input. Then once we have the integer input, then what I'm going to do is I'm going to put all my odd numbers in a stack and even numbers in another stack. Okay, so stack int odds comma evens, right? And then I am going to say for I in times n, and let's start it from 1 till equal to if I and 1. So if my I is an odd number, then I will push it onto the odd stack. Otherwise I will push it in the even stack, right? Okay, now in this stack, so whenever I need an odd number, I can just pop it out of the stack. Okay, now let's also make a what should I say, let's also make a vector of vectors. So this will be my answer vector. So answer, let's just call it matrix of n elements times vector int n elements, so n cross n matrix, and let all the initial elements be 0. Now what I'm going to do is I'm going to try to fill all my upper triangular matrix by by odd numbers, right? So till I am exhausted with my odd numbers, I will try to fill the upper triangular matrix with odd number. So I will just say okay, for I and for j less than equal to I. So now I am traversing in only the upper triangular matrix. If not odds dot empty, if my stack is not empty, then I will try to put an odd number here. So matrix of I and j equals to odds dot top and odds dot pop. So I will put an odd number here, and if it is empty, then I will just break out of this loop. And I will also and in the last loop, like if I am in the last boundary, I also need to count if if I'm lacking one element, because then I have to swap these, right? So I will make a bool variable here. So let's say bool check equals to false, and let's count the number in here. So count is equals to 0, and let's say count plus plus. Okay, and after this while loop I need to check if my I plus this count. So if I plus count is what should I say, if this number is even, right, mod 2 equals to 0, then I will say okay, check equals to true, right? Also I can say if odds dot empty, I don't think it will be empty, let's leave that. Now if my check variable is true, then I need to swap two elements. I will have to swap this n-1 cross n-1 to something here, right? So if my check is true, then I will just say okay, n-2 times n-2, no, not n-2, I have to say matrix 0 comma n-2, or should I say, let's say if this works, n-2 comma n-2, and then I have to put this to as a 0, equals to 0. Okay, now I have swapped these two elements. Once this is done, I can traverse my whole matrix again. So for I, for j, if matrix I comma j is not equal to, is equals to 0, then I will put an even number here. So I will just copy it. I don't think I need this if block here, and I will put even number here. Okay, and now once this is done, we can simply print our entire matrix. So for I, or I should say for auto row in matrix, for int x in row, let's print that x. I don't know why I'm making so many typos here. Okay, so now I think this should work. Let's see. I also need to add some base cases, like if my n is 1, then let's simply print 1 here and return. And if my n is 2, then we can simply print -1 and return, right? Let's see what it gives us the output. Now 1, 2, 3, why is this happening? So we have 1, 2, I think this is correct. Let's submit this and see if it works. Okay, so we got a correct answer, and I hope you were able to understand it. And if you did, kindly like this video and subscribe to the channel. I will see you guys next time. And if you want me to make another, if you want some editorial on some other problem, you can comment down and I will surely make an editorial video on it. So thanks guys, see you next time.